we are continuing our 6-part series in which we look at an overview of epidemiological study designs. And in part 5 of this series, we are going to talk about cross-sectional studies. We start with the difference between a case control study, a cohort study, and a cross-sectional study. We want to compare how do these 3 study designs differ: the case control study, the cohort, and the cross-sectional study. Now, in a cohort study, the starting point is people who are exposed and those who are not exposed. And we follow them up forward in time to gauge those who develop the disease and those who don't in both groups. In a case control, the starting point is those with the disease and those without the disease. And then we look backwards to assess whether they were exposed in the past or not. Now, in a cross-sectional study, the starting point is just the population at a given point in time. And at that same point in time, we assess the population for a suspected exposure. And those same people, we assess them for the disease of interest at the same time. So the cross-sectional study is done at a point in time. There is no follow-up. It takes a snapshot of the population. And that is why it is also called a prevalence study, because it generates prevalences of either the suspected exposure or the outcome at a given period of time. Now, the design of a cross-sectional study is as follows. Start with the general population. Determine the prevalence of suspected exposures and suspected outcomes at the same time. No follow-up. So I come in the population and I determine who has exposure X and who has a certain outcome. And then you compare the prevalence of the outcome of interest in the suspected exposed and the suspected non-exposed at the same point in time. You can also compare the prevalence of exposure in those with the disease and those without. Now, I'll give an example of a cross-sectional study. So I go to a district in Uganda, for instance, Iganga district, and I get into the population. I get people who are aged 18 years and above. So I assess them for, I assess their blood sugar, for instance. I assess their blood sugar and I determine those who have an elevated blood sugar or a raised blood sugar and those who don't have a raised blood sugar. At that point in time, I check their blood sugars and I determine those who have a high blood sugar and those who don't have a high blood sugar. Now, at the same point in time, I also assess their level of physical activity at that point in time. So I determine those who are physically active and those who are physically not active at that point in time. So I get the people who have a high blood sugar at that point in time. I find out those who are physically active and those who are not physically active. Then I get those with the normal blood sugar. I find out those who are physically active and not physically active. So in this study, I also have the exposure, which is the physical activity, and the outcome, which is blood sugar. It's just that the exposure and the outcome are assessed at the same point in time. So I cannot for certain say that it is the physical inactivity that led to the high blood sugar. Or it is the other way around, that the high blood sugar led to the physical what? Inactivity. So cross-sectional studies mainly generate descriptive information to describe the characteristics of the population. The primary objective is not comparison, but we can compare. The primary purpose of cross-sectional studies is to determine the prevalence of outcomes of interest. Just you determine the prevalences of outcomes of interest. We determine several descriptive measures. Like for instance, for continuous data, we determine means, modes, medians to describe the population at that point in time. We determine frequency counts and proportions or prevalence for categorical variables like high blood sugar and low blood sugar, high physical activity and insufficient physical activity. And they help us to formulate hypotheses. Prevalence, as you know, is given by the number of new and existing cases in the population divided by the number of people in the population, that is the population at risk. Now, however, although cross-sectional studies are not designed for comparison, in several cross-sectional studies we compare, we do comparisons. Because you see, we have a suspected exposed group. For instance, in the example I have given, the people who don't have sufficient physical activity. Then we have the non-exposed group, that is the people who have sufficient physical activity. Then we have some outcomes, like for instance, the people who have a high blood sugar and the people who have a normal blood sugar at that point in time. So we can compare. We can compare in two types of designs of cross-sectional studies. We can take a single sample, and we partition that sample into people with an outcome of interest, that is, for instance, people with a high blood sugar and people with a normal blood sugar. So in that case, we call the people with a high blood sugar cases and the people with a normal blood sugar as controls. And then we compare the different suspected exposures. I'm calling them suspected exposures because we are not sure whether they occurred in the past. We've just found them out at that point in time. So we can compare from a single sample. Or we can set up a cross-sectional study in which we have equal groups of the exposure or outcome of interest. So we get we screen people for high blood sugar, let's say 100 people with high blood sugar and 100 people without high blood sugar, and then we compare several exposures. No, so this is an illustration. We can compare within a single sample. We select a sample of, say, 600 people. We determine the prevalence of the disease. Say it is 20%. So 20% of 600, it means that 120 people are affected with the disease and 480 people are not affected. So then we get the 120 people, we look at their exposures, and the 480 non-affected people, we look at their exposures, and then we compare the prevalence of exposures in the cases and in the controls, which is like a case control. But remember that these exposures are occurring at the same point in time. So these comparisons are done in unequal groups. So this can be done if you have a sufficient sample size that will give you sufficient numbers of affected people. If you get a very small number here, like 5 cases, then you cannot compare. On the other hand, comparing fixed groups, that is, these are also called comparative cross-sectional studies. They're like essentially like case control studies. We screen for a fixed number of affected people and an equal number of unaffected people. At a point in time, we determine the prevalence of different suspected exposures and we compare them. And the groups are equal, so we don't worry about sample size of this getting very small samples. However, we cannot determine overall prevalence since the groups are predetermined to be equal. So the findings of a cross-sectional study can be summarized in a 2-by-2 table. We have cases and we have controls. So these are people with the disease or outcome of interest and people without the outcome of interest. And the exposure, here it's not where exposed, but exposed now. Exposed now and not exposed now because the exposures are being determined now. So we can compute the odds of exposure among the cases and the odds of exposure among the controls in much the same way as we did for a case control study, and we get the cross product AD over BC. But being that both the exposure and the outcome are determined at the same point in time, and we're not sure what preceded the other, we can also analyze the cross-sectional study as a cohort study. We can analyze as a cohort study. So we get the exposure of interest. That means exposed, that is not having physical activity, and having physical activity. And then we determine those who develop the disease, that is a high blood sugar, and those who don't. And we can compute a relative risk. So we can interpret them in different ways. What are the advantages of case control studies? They are rapid. They are conducted over a short period of time. They are relatively inexpensive, and they usually use population-based samples instead of convenient samples, so they are easier to generalize. The main disadvantages is that the prevalent cases may not be representative of all cases. So because it's a prevalence study, it gets people with high blood sugar now, but it eliminates those who maybe died very fast or recovered very fast from the high blood sugar and are not prevalent now. So it may not be representative of all cases of high blood sugar. And then the second and very important disadvantage of these types of studies is that the exposure and the outcome, that is the suspected disease and the suspected exposures, are assessed at the same period of time. So you cannot be sure which one caused the other, whether it's the high blood sugar that caused people not to exercise or to do physical activity, or it is the physical activity, the lack of physical activity that led to the high blood sugar. And we usually use the term, the late term, the chicken and the egg affair. We are not sure whether the chicken was created before the egg or the egg came first. So the basis for ascertaining causality is weak. We are not, although we find even if we find a strong association, say, between lack of physical activity and high blood sugar, we cannot certainly say that that relationship is causal, that lack of physical activity causes a high blood sugar, because we are not sure what preceded the other. But we have a good level of evidence that, nevertheless, that can be tested elsewhere. So what is the application of cross-sectional studies? Cross-sectional studies are one of the most frequent epidemiological study designs in use because they are quick and they provide rapid, formative, descriptive information. Many surveys and rapid assessments use this approach. So in usual practice, we mainly make use of surveys. And they are a common way of assessing epidemiological characteristics of populations. They are a gold standard for rapid description of populations. And despite the challenges with causality, they still provide a good level of evidence associating given exposures to disease. And examples of surveys at a national level are the National Health and Demographic Survey, the HIV/AIDS indicator surveys, the national non-communicable diseases surveys, the living standards measurement surveys, and other surveys that you may know of. And then we also have what we call panel surveys, which are repeated surveys. So we get to a population, we take a sample, we do a survey, then we repeat that after every 5 years. Over time, it becomes like a cohort, and it can tell us whether there are certain things that are changing in that population over time. For instance, we can do household expenditure surveys over time. We can do resilience assessment surveys to see how resilience changes in a population over time. For instance, the FAO food security surveys. So in this session, we have looked at one other study design that is more rapid, more easy to implement than the other epidemiological studies like the cohort studies and case control studies. but it has one main disadvantage, being that both the suspected exposures and the outcomes of interest are assessed at the same point in time, so we don't have a temporal relationship, and this weakens our case for causal inference. Now, in the last part of this series on overview of epidemiological study designs, we are going to look at experimental studies. Thank you.